Hello everyone. So I'm come back with section 8.3 matrix operations. Um, so we given let's do an example, right? Example one, given matrix A, which is 2, 2, 3, 1, 4, 1. Okay, so we're gonna say what are the dimensions of the matrix A? Okay, so the dimension of matrix A in here should be uh, how many rows do I have? 3 rows, right? So 3, oops. So 3 rows and 2 columns. Okay. So that's gonna be row by column. Okay. So now problem B say what are the entries at A31 and A22? Okay, so A sub 31 mean the entry in entry at row 3 and column 1. Okay, so row 3. So I have 1, 2, 3. Row 3, column 1. Column 1. Okay, so that should be this guy, number 3. So A31 equal to 3. Okay. And what is entry for A22? So A22, similarly, it should be the entry at row 2, column 2. Row 2, column 2. Okay, so 4. Okay, so that is a way to talk about dimension and entries. Let's move down. All right. So example 2 say adding matrix. So addition and subtraction of matrix is only possible when the matrices have the same dimension. Okay, so what's the dimension of A? We have how many rows? 1, 2, 3. 3 rows. 3. Okay. How many columns do I have? 1, 2, 3. So 3 by 3, right? Clean this up. What about the dimension for oops, the dimension for matrix B? We have also 3 columns. Sorry, 3 rows by 3 columns. Right. Always remember that it should be row by column, row by column. Okay. So now we're gonna try to find the sum. It's gonna be like this. So A plus B will be, you're gonna take the entry the entry, the addition between the entry in the same position. So these entries will add with this entry, right? So 2 plus 6. Okay, that is the first one. Then negative 10, you're gonna add with the entry in the same position at B. So negative 10 plus 10. And so on. Negative 2 plus negative 2. So negative 2 plus negative 2. Okay. Now we're gonna move down. So 14. Let me use the other color. So 14 and 0, right? So 14 plus 0. And 12 plus negative 12. Okay, and then 10 plus negative 4. Now, for the last row, 4 plus with negative 5, which is minus 5 later. So negative 2 plus with 2. And then 2 plus with a negative 2. Okay. So now, if you simplify, you will get 2 plus 6 equal to 8. Negative 10 plus 10 will be 0. Negative 2 plus negative 2 will be negative 4. 14 plus 0 is 14. 12 plus negative 12 going to be 0. 10 minus 10 plus negative 4 going to be 6. 4 plus negative 5 going to be negative 1. Negative 2 plus 2 going to be 0. 2 plus negative 2 going to be 0 again. That's going to be the answer for part A. Let me gonna circle it, right? So find the difference. Okay, so that means A minus B. So same thing, but just instead of adding, you're subtracting. So subtracting between the same entry, between the entry with the same position. So I have 2 minus 6, negative 10 minus 10. And what else? Negative 2 minus for negative 2. 14 minus 0. What else? 12 minus negative 12. 10 minus negative 4. 4 minus negative 5. Negative 2 minus 2. 2 minus negative 2. Okay. So now you're going to simplify it. 2 minus 6, negative 4. Negative 10 minus negative 10, negative 20. Oops. Negative 2 minus for negative 2 is negative 2 plus 2 is 0. 14 minus 0, 14. 12 minus negative 12, which means plus, so 24. 10 minus negative 4, which is going to be 14. 4 minus negative 5, going to be 9. Negative 2 minus, minus 2, going to be negative 4. And then 2 minus negative 2, going to be positive 0. Okay, so you're going to have the answer as this matrix. So I'm going to circle it. Okay, that should be the answer. So notice that. Notice that. We need same dimension. Need same dimension. To do addition or subtraction for matrices. Okay, if you have different dimension, then you cannot do it. Okay, if different dimension, you cannot do it. You can do addition or subtraction. Okay, so now let's move down. Example number 3, we're talking about scalar multiplication. Scalar multiplication is kind of like the multiplication between a constant number with the matrix. So let's say multiply matrix A by the scalar 3. So I have A, so multiply by 3, gonna be equal to, I can write as 3 multiplied by A, and that's going to be 3 multiplied by 8154, right? And what we do is you just gonna multiply number 3 with each element here, with each entry here. So like you do distribution, right? So you're gonna have new matrix as 8 times 3, 8 times 1, and then, sorry, 3 times 1, 3 times 5, and 3 times 4. And in short, you're going to have 24, 3, 15, and 12 for the matrix as the answer. So know that in general, you have like K multiplied by A, B, C, D, something like that. Then that's going to give you K of A, K times B, K times C, and K times D, something like that, right? Okay, so let me circle this by other color. Oh, no, circle all this. Okay,